In that moment, you see the whiteboard, no?
Yes.
Okay. So let's focus today in solution of the equations. Exponential equation and logarithmic equation. Some equation is possible solving by the traditional way, que is que you change both sides of the equation, right and left, in order to express it using common base. It's a classical example because I know que 1/3 is 3 raised to the 1/2, -1, sorry, and 9 is 3 to the second power. Okay, so now we have the base, the common base is 3. Now you copy. 3 to the -1 raised to the 2x plus 5 equal, instead of 9, 3 to the second power raised to the x plus 3. Entonces we have two levels of exponents. Your multiplication is the rule. So by basically it's 3 to the minus parenthesis 2x plus 5 equal 3 2 times parenthesis x plus 3. Entonces in this specific moment, I see that we have two exponential and the base is the same, therefore the exponent is the same. So you copy minus parenthesis 2x plus 5 equal 2 times x plus 3. And magically, you convert the exponential equation to linear equation. And the rest is baby elementary algebra. You distribute it, minus 2x minus 5 is equal to x plus 6. Let me try to move, for example, minus 2x stay here, minus 2x I bring to the other side, 6 stay, 5 I bring to the other side. We have minus 4x equal 11 divided by -4 both sides. X is equal minus 11 over 4. Boom. Do you understand the logic of the solutions?
Yes.
Okay. Any question? This is a review. Now I appreciate so much. Okay, any question you have, let me know. I would like to explain. I enjoy explaining. Okay, now 13 is similar because the number involved is 1/5 raised to the x plus 2 equal 125 raised to the x power. Pero in one corner of the piece of paper, I know you copy 1/5 is 5 to the -1. And 125 is 5 cubic. Because if you multiply 3 times 5, 5 times 5 is 25, and 25 times 5 is 125. And you replace, no 1/5 anymore, is 5 to the -1 exponent raised to the x plus 2 equal 5 cubic, is equivalent 125 raised to the x power. Now multiplication, the exponent is 5 minus x plus 2 equal 5 3x. You know very well in this moment you delete mentally the base and you have minus x plus 2 equal 3x. Okay. Distribute is minus x minus 2 equal 3x minus x minus 3x equal to positive minus 4x equal to positive divided by -4 both sides is -2 over 4, and you can reduce in lower term is -1/2. Boom. Finals. Super clear or super confusing?
Clear.
For you, but I asked for everyone. Apolinario, Apolinario. Apolinario, do you understand very well the problem I solved for you yesterday?
Yes, yes, it was helpful.
Mhm.
I
How,
understand now.
how do you feel in that part?
But that was like a tricky part. That's why I asked for help.
Okay, let's do it 14. 14 is different because 14 is equation, exponential equation that we cannot manipulate both sides in order to express in the common base. No, 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 it's impossible because 5 and 4 never matching, you know. Now, entonces definitely I need to apply logarithm. What kind? Of course, standard, and we ending in the calculator. So you apply logarithm both sides, logarithm of 5x plus 4 equal logarithm of 4 raised to the x power. And you apply now the property number 7. Property number 7 is magic because the exponent and this exponent go to the front. Entonces x plus 4, of course, binomial, entonces I enclose the parentheses to don't confuse it by myself. Logarithm of 5 is equal x time, this is time, of course, this is time, logarithm of 4. Entonces this equation is not exponential anymore, no, it's linear. Maybe it's confusing for you because we are logarithm of 5, but this is just a number we can compare in the calculator, but don't worry for this too much. Let's continue. My goal is solve for x. So you distribute it. This is x multiplication, logarithm of 5. Of course, standard plus 4 multiplication, logarithm of 5 again. Is equal x times logarithm of 4. Okay, so I try to group in the term que contain x. So I move this to the left. There are many ways. No. Okay, let's do it in a different way. Let's do it in a different way. For example, it's a question. The question, you know, the question is very, very nice. I bring down this. There are many ways. And any way that you're doing correctly, you get the same answer. This is x logarithm of 4 stay minus x logarithm of 5. Entonces yo factorado x and stay inside the parentheses or bracket because bracket is using when you have different level of parentheses logarithm of 4 minus logarithm of 5. Okay, cool. Now who is x? X is 4 logarithm of 5 division logarithm of 4 minus logarithm of 5 is equal x. In the moment you can put in the calculator, but personally, I don't like. I prefer condensing the logarithm, of course, in the top and the bottom, in only one, using the property number, in this case, property number 7 in the top and property number 6 in the bottom. Remember, property number 6 is using when the subtraction, when this addition is property number 5, is multiplication. So now basically the property number 7 allow me this 4. I put like exponent, so 5 to the 4 power is obviously 625. No? Let me check the calculator just in case. See, yes. So this is equivalent to write logarithm of 625. Where come from? 625 was 5 to the 4 power. Because using the property number 7, this 4 I put here like exponent. And property number 6 condensing only one logarithm, entonces es 4 over 5. Okay, 4 is a positive in the top, and 5 is a negative in the bottom. Okay. This indicate me, of course, this answer I prediction. This answer, the top part is positive, but the bottom part is negative. Why is negative? Because logaritmo of base 10, of course, que es de estándar, ¿no? Of the one number, que es 4 over 5, que es less than 1, it's obvious that the answer is negative. But I don't care. I put on the calculator like that. Logarithmic of 625, close the parenthesis, division, and I press again the log of the 4 over division 5. Close the parenthesis, don't forget to close the parenthesis, and you get negative 28.8. They want, the problem say 4 digits, no? 4 digits. So I copy completely, I don't care. 5, 0, 2, 6, 9, 7, 6. At least in my display of the calculator, 1, 2, 3, 4 is needed. You analyze 6, the next digit is greater than 5, so you increase it. The answer is minus 28.8503. Boom. Any question? What part you don't understand very well? No question, Anika. Okay. The problem is always happen. Can you understand when you are doing? I am doing, you understand. But you sometimes won't be able to do by yourself. Entonces you need to imitate somehow at the beginning. You imitate, you watching the video, and the video, entonces, oh, what is the first step? And you need to organize by yourself. I cannot do that. This is by yourself. The organization, so because any procedure in mathematics is a sequence of steps that you need to organize step 1, step 2, step 3, step 4 until you finish. Okay, what is the next problem? Well, the next problem is similar to the 15 is similar to the 14. We have classical example in which it's impossible manipulate both sides in order to express a use the common base. However, bueno, I know the mathematician create the logarithm, que the logarithm is amazing, is fantastic, because convert the exponential equation in linear equation or quadratic, depende, no? Depende on the equation, pero at least remove somehow the exponent. When you apply logarithm, suppose que apply LM, bueno, you apply either way, standard. 4/3, and this exponent I know que is go to the front, and this is, you know, it's binomial, entonces es binomial, I like so much enclosed in the parenthesis, no? Because this logarithm of 4 over 3 multiply 1 by 1 inside. So you put without parentheses, you understand wrong que logarithm of 4 over 3 multiply only x and 1 do not participate in the game. It's not true. Entonces it's equal x times el logarithm of 5. Okay, distribute now. Multiplication. This times this. This times this is natural logarithm of 4/3 minus x times natural logarithm of 4/3 again equal x logarithm of 5. Well, I propose you doing in that way. This guy stay. I move this que es negative to the right hand side. Entonces es x logarithm of 5 plus x logarithm of 4/3. Okay, so now I factor out x because my goal is solve for x. Now finally, one possibility, no, of compute this is you divide this divided by this. And you can write like that in the calculator. However, I do not recommend, because you need to be careful with the parentheses. It's okay. Suppose in this case I see you can apply property number 5 here. But that part is completely optional. If you are clear in the parentheses of the calculator, you can write, you typing in that way. But okay, I do not recommend that. I recommend always make easy, and you condense in this logarithm only one, is logarithm of the multiplication. 5 times 4/3 is obvious 20 over 3. Yes or no? Because 5 times 4 is 20, no? And 5 is a whole number. I believe or suppose or understand que el denominator is 1. Do you follow me? Now calculate. I don't know why I select natural logarithm, but it doesn't matter. You know that the answer doesn't change. If you select LOG or LM, it's the same. 4/3 divided by another logarithm ln of 20 over 3. It's 0.15. 0. I just copy the thing I saw in the display right now. 1641475. But they want 1, 2, 3, 4. Oh, next digit is less than 5. So I delete everything. I just copy that. Boom, boom, boom. End the story. The prediction for 4/3 is greater than 1. So this logarithm would be positive. And 20 over 3 is greater than 1, of course. So it's positive. Positive divided by positive is positive. Exactly, we get that. Any question? Look like trivial, easy, elementary, kindergarten.
It's very easy, Professor.
Okay, I hope so. Okay. Now, let's move on to the question 16, que bring me new situation. Look, this equation, when you see at the beginning, look like horrible. Because it uses 2 raised to the 2x plus 2 raised to the x minus 12 equal to 0. Wow, what the hell? It's not the classical format that you have exponential in one left-hand side and another exponential in the right-hand side. In this case, it's different, but this, resemble a little bit the equation that you solving in the chapter 1. Remember, in the chapter 1, we study what kind of equation is called a quadratic form. What is the clue of the identification, the equation quadratic form? Well, we have one expression and we have another expression. They are similar, except one exponent is twice another exponent. Okay, and remember, we solving this quadratic equation by the substitution u. And the substitution u always, taking like a smaller exponent, que es 2 to the x. And when you rewrite the new equation using the auxiliary variable u, always help me to convert the complicated equation, at the beginning is exponential equation, and one quadratic equation. This is u by definition, and this is u squared. Do you understand this step?
Yes, Professor.
Now we face the solution of the quadratic equation. And you remember that we have many ways to solve this. The quadratic formula, the factorization, complete square, blah, 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 blah. What do you recommend me to do that? By factorization, or remember my recommendation always is, you spend 2 seconds to see if it's possible or not by factorization, no? Si you don't see the combination, they open the door of the factorization, well, okay. I go to the quadratic formula, and the quadratic formula for sure give me the solution. It's too long, but it's reliable. And the factorization is weak, but it's easy and fast. What do you think? Factorization or quadratic formula?
Factorization.
Because you see the combination, Elisa?
Yes, 4 and 3.
4 and 3. Elsa saw that the combination of 4 and 3. Remember, it doesn't matter the position of the factor, no? Because it's a factor multiplication, no? And you can interchange. And what is sign? What is the sign? I'm confused. What is positive? What is negative? Or both positive or both negative?
4 is positive and 3 is negative.
Absolutely perfect. Now you separate each factor one by one. It's obvious that this factor upon u equal -4, and this factor upon u equal 3. I feel no. Remember the story was I have a complicated equation, exponential equation. Using this technique, quadratic in front, I convert to quadratic. But I change the variable. The change the variable helped me to simplify the thing. But now I need the value of the x, not the value of the u. No, I don't care u. It's not important. X is important in the final answer. Now I need to go, and I need to investigate the value of the x. But the value of the x associated with the u. So I split the paper into bar. For u equal -4. And for u equal 3, I solving this. So who is u? This is u. Expression that I used at the beginning. So I replace 2 to the x equal -4 and 2 to the x equal 3. Cool?
Yes,
Yes.
Professor.
Entonces now, in that part, I see something weird. Because the exponential function never give me negative solution. Because I know the graph of the exponential is this. So basically, the thing I try to find in that part is what is the common point between one exponential, is like that, and -4, is a line, horizontal line like that. It's obvious que no. No solution. Yes or no? Do you see or no?
Yes.
Suppose that some students don't remember very well the exponential. Well, you are in big trouble if you don't remember the exponential. But you apply, you don't know. You don't know that part. And you try to using traditional way. Traditional way, apply logarithm both sides. You apply logarithm log of 2x equal log of -4. Immediately you realize, wow, no solution because logarithm of the negative number is impossible. Out the domain. So that's a confirmation. This is impossible. Suppose you don't know. You put in the calculator, and the calculator say emergency out the domain. Entonces, no solution. Do you understand very well that the exponential function never give me negative number? And this, yes. This is yes. This I did before. I remember doing this. Logarithm of the 2 to the x equal logarithm of 3. Do you see, guys? In this example, I omit the parentheses. I want to always enclose in the parentheses, but no strictly necessary. So when you are doing fast and you omit the parentheses, everyone understands. So x go outside, property 7. So x times logarithm of 2 equal logarithm of 3. Now x alone is logarithm of 3 divided by logarithm of 2. And the rest is calculated. Remember the 4 decimal places approximation. Entonces el logaritmo de 3 divided by, guys, you are confident in using the calculator? Oh no, well, you never practice. Eh? Okay, it's positive. The answer is 1 point. Okay, I ask you a question. You practice with the calculator or no?
Yes, I practice with my
Yes.
calculator.
Okay, cool. 501. 4 decimal place, 1, 2, 3, 4, 6. 6 is greater than 1, so 50. 1.5850 is the final answer of the hour problem. Okay. Let's move on to the last part. I suppose que today we finish early, no? Que es the logarithmic equation. Logarithmic equation. 17, 18, and 19. Okay. 17 is logarithmic. I want to copy here. Base 4 of the x minus 7 plus logarithm base 4 again of x minus 7. Wow, it's a coincidence. What the hell? Equal 1. Well, there are many ways. Many ways. Many ways. One possibility is, well, it always happens that the step 1 and the solution of the logarithmic equation is condensing. So you have 2, 3, 4, 5, 6, I don't care how many logarithm you have, you condense it in only one. And you apply the property number 5 because it's plus. And property number 5, multiplication. So the logarithm of base 4 of the x minus 7 times itself, no? Because it's a coincidence. Not always happen, but in this case, happen is the same. You can write like that, or you put a square, either way. I don't know, what do you consider correct? Equal 1. Do you follow me? So far?
Yes.
Yes.
What is the next step to visualize more clear? Convert to exponential. I want to see this arrow in the test, and you put to exponential. Entonces, help me to understand the step that you are doing. The base is 4, the exponent is 1, equal x minus 7 squared. Oh, entonces now in that moment, we have one quadratic equation. Que es, let me copy separately here to understand x minus 7 squared equal 4. 4 to the 1, you know, it's invisible, it's 0.1. So this is ready to apply the famous square root method. You can expand it and you determine A, B, C and apply the quadratic. You can, of course, but it's too long. No. In my opinion, better is apply square root both sides. X minus 7 cancel out each other. Square root and square power, no? Entonces we have square root 4 get 2, but don't forget plus and minus. That's the only disadvantage of this method, no? Okay, you need to remember plus and minus. Now x alone is equal 7, and move 7 positive plus or minus 2. We have two solutions. 7 plus 2 is 9, and 7 minus 2 is 5. And as always happen in the logarithmic equations, you need to verify, you need to check it. So you split the paper again in two parts. Checking for a classic. I don't see the checking, no credit. Checking for 9 and checking for 5. The problem is in the manipulation, not intentionally, of course, you introduce extraneous solutions. So you need to verify the solution in order to declare the solution set is 9 and 5. No, I need to check it in the original, right? So logarithm of base 4 of 9 minus 7, que es 2. So I'm plugging in 9 here, and 9 minus 7 is 2, plus logarithm base repetition is the same, should be 1. I claim this because I'm not sure that this statement is true. It's obvious it's true because when you apply the property number 5 here again, you have logarithm of base 4 of 2 times 2 gets 4. And you know very, very, very well that when there are coincidence between the base of the logarithm and the argument, the answer is 1. So 9 is good. Boom. And 5, no. Because immediately you see 5 here, if 5 minus 7 is negative 2, and you start writing here, logarithm of 5 minus 7 is negative 2. Ooh, no, 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 because logarithm of the negative number is totally undefined. Undefined means que es error. Therefore, I know solution is 9 only. Solution set for this logarithm equation is 9. Cool?
Yes.
But I need to erase something. You let me know? You let me do the eraser?
Yes.
Okay. Erase everything. No everything, not the paper, only the word. Guys, I see something. Some students send me the test only with the answer. So you send me the test with the answer, I put 0. This is nothing. Another student, no, another student doing something, but something stupid. When I see, I detect it immediately. When you copy for another guy, okay, you don't know exactly what you copy, and you copy nonsense thing. Because I detect it, no, he don't know anything, 0 again. You have correct answer. I don't care the answer. I care the word. Okay? Okay? Okay. What is the next? Well, the next is 18. 18 say logarithmic of x plus 3 equal 1 minus logarithm of x. So for x. Well, no specification the base here, no number here. Entonces, I suppose that when this situation happens, it's because the base is 10, and we are talking about the common logarithm. By default, everyone in the world, any student in the university, when they face that problem, no base specification, it's because these logarithms are common, standard. Okay, cool. But I need to move everything to the same side because I remember that the professor explained me I need to condense it. So using the famous property number 5, we condensing this logarithm in only one. Get the multiplication x times x plus 3. I put a bracket here because the bracket is to understand the argument inside the new logarithm. And the parentheses indicate that we have multiplication here equal 1. Now ready to convert to exponential. Okay, you realize that the base is 10. Remember, the base is 10 at the beginning, right? So when you convert the problem to exponential, obviously the base is 10. The base is 10. Entonces, you copy here a big 10, get the base. Okay, by the way, is invisible here. Invisible, but I know conceptually. Okay, it's 10. Okay. Now the exponent is 1. Oh, nice. And this 1 is invisible also because 10 to the 1 is 10. Okay, so I erase. Not necessary to write useless number. And this is x plus 3. Yes or no? Do you understand very well the conversion from logarithmic statement to exponential? Actually, it's not exponential because the exponent is 1. And now we face a quadratic equation. Yes or no? 10 is equal x squared plus 3x. Okay, I write standard. I write standard because I know very well that when you solve the quadratic equation, so I move 10 to the other side, minus 10 equals 0. This is my equation. So you ending, not always, but frequently in quadratic equation. That is a reason that I explained at the beginning of the semester that the solution for the quadratic equation is fundamental to pass this class. And now, again, I have the different possibility, no? You determine A, B, C, apply the quadratic formula, or factorization. What do you think?
Factorization.
Mm-hmm. And what is the combination that open the door of this factorization?
5 and 2.
5 and 2. Because 5 times 2 is 10. And somehow 5 minus 2 is 3. What sign? What sign? What sign? What sign? Same sign or different sign?
Different size.
Who is positive? Who is negative?
5 is positive and 2 is negative.
Excellent. So this factor generates solution negative 5. And this part generates solution positive. It's obvious that the solution negative. You should look at that. Look at that. I come back at the beginning. Logarithm negative 5 plus 3 is negative 2. No. Negative 5 doesn't work. This solution doesn't work. It's obvious, right? And 2 maybe. I don't know. Let me try to check it for 2. Basically, I copy my original. Remember the checking always we are doing on the original. Entonces logarithm of 2 plus 3. I replace 2 here and 2 here. Logarithm of 2 plus 3 is 5. Should be cleaned up. 1 minus logarithm base 2. Okay, to prove that. Some students say, well, okay, put in a calculator. Okay, you put in a calculator, you get the same answer. We are decimal. It's okay. However, elegant way to do that without calculator. No, either way, guys, I accept either way. Any smart, correct way I can accept. You move again using the property number, no property. First of all, you move logarithm of 5 plus logarithm of 2 should be 1. And you condense in this logarithm in only 1. And this is the multiplication 5 times 2 is 10. Wow, fantastic. Y I know que D4, the base is 10, the invisible 10. And 10 and 10, same argument, same base is equal 1. Okay, it's true. And the answer 2 is perfect. Solution set for this equation is 2. Logarithmic equation. What do you think? 100 point everything? Everyone?
Yes.
Yeah.
Yes.
Last one. Entonces, ¿son students enroll with me next semester o no? ¿No? Trigonometry, precalculus? No? Okay. Because you don't need to take, no? So we have this conversation, no? Pero another student, yes. Apolinario, you need to take precalculus and trigonometric or no? Apolinario.
Yes.
And you are already enrolled or not yet?
No, yeah.
Pero no, porque you don't like in person, no? You need like that NDC on NDC live, no?
No, I would like to take in person.
And with me, no again, no?
Maybe I haven't enrolled in any class yet, so.
Yeah, it's Tuesday and Thursday. It's a continuation. So you enroll in both. Because you take one and I read the second. It's back to back. Okay. hurry because never we have, in this moment, yes, we have seat. Pero en one moment, entonces es full the class. I need to, it's more complicated. I need to ask authorization to enroll you. Entonces, es like you reserve in the hotel. And pero you don't pay. If you don't want to the appointment, no problema. But you reserve your place after, you know, the life is complicated, no? Entonces maybe you have another plan and no good for you. Okay. Okay, entonces I copy exactly the same. This is the same. It's the same logarithm base 10 because the base is omit. But you try to put together in the same side the logarithmic. So I move this guy to the left. And you apply the property number 6. Property number 6 is logarithm of division 2x plus 1 divided by x minus 2. And this is the new argument of this new logarithm. Okay, now we convert it to exponential. I know that the base is 10 again. Uy, I'm exponent 1. Nice. Gets invisible. I like that. And is equal to x plus 1 divided by x minus 2. And this, we have equation. This is like a rational equation, but it's super easy. Look, you consider like a proportion, no? And you apply cross multiply. You multiply 10 times x minus 2 equal to x plus 1. It's 10x minus 20 equal to x plus 1. 10x minus 2x equal 20 positive plus 1, 21. This is ax equal 21 divided by a both sides. X is equal to 21 over a. Wow, we are answer, but I need to check it. Maybe it's a good candidate to be solution because it's positive. However, I need to check it. Checking for 21 over a. So you replace in the original or this, doesn't matter. This is, you can use this. And the reason that we can use it is that the only transformation we are doing is move. It's equivalent 100%. Maybe when you have no equivalences, is when you convert to exponential. But in this case, you can use the second equation, que is equivalent to the original. It's a logarithm of 2 times 21 over a multiplication plus 1 minus logarithm of 21 over 8 minus 2 should be 1. The only ugly part in this problem is the manipulation of the fraction. But don't worry too much. Let's do it step by step. Look. Use simplification a little bit. These 2 and this is 4. Basically, 21 over 4 plus 1. Que es 21 over 4 plus 4 over 4, no? Oh, no. Let's do it like the classical idea. You find the LCD, que es 4, is a 21 plus something, pero the next number is 4 times 1, que 4 is 25 over 4. So basically, so far, we have logarithm of 25 over 4 minus something. And let's do in that part. That part is 21 over 8 minus 2. Again, we are doing LCD, que is 8. In that case, 21 minus 16, no? Because 8 times 2 is 16. The 16 divided by 8 is 2. Now 5, no? 5 over 8. Okay, entonces minus logarithm of 5 over 8 should be 1. I need to prove this. Well, entonces you apply the property number 6 in that case. And the property number 6, well, you're condensing this logarithm in only one. Entonces, logarithm of, what the hell? Is division. Division who? 25 over 4 and 5 over 8, no? Okay, let me copy. This is the argument of this new logarithm. Okay, I need to prove que es 1. 25 over 4 divided by 5 over 8 is easy. It's 25 over 4 times reciprocal, 8 over 5. Oh, easy. You simplification. Divided by 5, 1. Divided by 5, 5. Because 25 is 5 times 5. Divided by 4, 1. Divided by 4 is 2. 5 times 2 is 10. And 1 times 1 is 1. It's invisible. This is equivalent to say logarithm of 10. A logarithm of 10 is 1? Yes. Because when the base is 10 and they are coincidence is 1. Okay. The solution 21 over 8. I know it's weird, but it's good solution. Question?
No.
Okay, so we finished the course, guys. I enjoy teaching this. I hope everyone doing okay. No problema. Don't complicate your life and my life. And on time, you send the information required, and I grade, and that's it. Okay? If you want to take with me next semester, I am available. Try to find, my name. Okay? Cool. Bye-bye. Have a nice days, and have a nice semester.
Bye, Professor.
Thank you.
Bye.
Thank you, Professor.